All right. So review of sections 9A through D, kind of synthesize what we know about exponential growth and decay, E, and applications of exponential functions. All right, a fungus grows continuously at a rate of 0.8% each hour. If you start with 200 grams of the fungus, how much will you have after 10 hours? How much will you have after 20 hours? And then how long will it take for the fungus to double in size? So things that are being pointed out. This is continuously, which means it is this equation, the PERT equation, okay? So I want to take 8% and make 8% 0.008. Okay, so make it a true decimal. So we start with 200 grams. So A equals 200 e to the r 0.008 t. So what we're going to do is we're going to plug 10 and 20 in here. And if we do that on the calculator, and I'll just do it on the handheld. Let's see. 200. Where's my E button? There it is. To the 0.008 times 10. So the 0.008 times 10 is an exponent. If you do that, this means after 10 hours we have about 217 fungus. I rounded it to the nearest whole number because I don't think we're going to have a decimal amount of fungus. And then same thing with the 20 hours. Second e to the 0.008 times 20. So 0.008 times 20 is the exponent. So this would tell us we have rounded about 235. 235. I can't do that. About 235 fungus. Does everybody feel comfortable being able to plug that in? You don't necessarily have to use this calculator, but one of the TI calculators you have okay finding E. If you get stuck on it, let me know. If you can't find E, I'm not testing you to know if you know where buttons are on the calculator. And then how long will it take for the fungus to double in size? So how can we know when it would get to this? So what you should do at this point is start reducing it. So you'd get 2 equals e to the 0.008t. Okay? So question for you. At 10 hours, it went to 217. Is 217 double of 200? No. Is 235 double of 200? No. So I got to plug a value bigger than 10 or 20 in. Okay, so I'm going to go, because I can just do the E, I'm going to go, oops, clear. Second E, let's plug in 0.008 times 40. That doesn't work. Let's do the same thing, 0.008 times, let's go with 100, see what happens. That's a little bit too big. So what I'm doing is I'm just trying to isolate a value close. And we're just kind of, narrowing it down. It's like higher or lower. Shoot, wrong button. 0.008 times 90. So at about 89 to 90 hours, it would have doubled. If I plug 89 in, I get slightly less than 2. If I plug 90 in, I get slightly bigger than 2. So somewhere in there. So if you gave me an answer, one or the other, or kind of say, hey, somewhere in between. And again, my friends, all I was doing is I was just trying to figure out what could I plug in for t that gets me pretty close to 2. Is that okay? So that means that there is a little bit of a leeway, but just make sure, does everyone feel comfortable plugging that into a calculator? Anyone like, ah? Again, if you can't find the E button on the calculator, ask me, and I'm happy to find it for you. All right, a 5-year-old car is now worth $18,500. The average annual rate of depreciation on the car was 14%. How much was the original sales price? Ooh, okay. So I'm going to turn 14% into 0.14. It's a 5-year-old car that is now worth this much. So I have A equals P 1 minus R raised to the T. Okay? We know that it's that equation because it doesn't say it was compounding or anything like that, monthly or weekly or anything like that. So we have an $18,500 car. We don't know what P was. If I go 1 minus 0.14, that gives me 0.86. So this is 0.86 that we're plugging in here, raised to the T. Okay, oh, and they said it was a 5-year-old car, didn't they? That T is a 5. So what I'm going to do is I'm going to go 0.86 raised to the 5th. So this is now going to give me 18,500 equals P times 0.470. Algebra 1 question here. P times a quantity, so I'm going to divide each side by 0.470. So our 5-year-old car that was worth $18,500 after 5 years old is now going to be worth 0.470. Looks like the car's original price was rounded to the nearest penny. 39,000. Whoa, 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 whoa. Oh, man, I'm making up stuff. 39,361.70. That was the original price of the car. Seem okay? That one I didn't have to kind of guesstimate numbers. I was able to plug it in. Yes, you should know how to go 0.86 raised to the 5th power on a calculator. Again, if you don't remember where the caret key is on a calculator, ask me. I'm not testing you to see if you know where the keys are on the calculator. I'm testing if you can get the mathematical content. I will make sure I give you all of the rate equations, the PERT and the 1 plus or minus R raised to the T, the 1 plus or minus R over N raised to the NT, things like that, where it's the number times compounding. All right, if you invested $2,400 3 years ago, it is now worth $2,664.49. If it was compounded quarterly, so this means I have an N value being 4. What is the interest rate? So I need to figure out what the rate is. That's unknown. So this is going to be this equation. 1 plus R over N raised to the NT. Okay? We know that it's going to be that equation 1. It's growing, so it's 1 plus. The R over N to the NT is because it has the compounded quarterly. So they tell us that it's now worth $2,664.49. We had originally put $2,400 in. 1 plus our rate, we don't know our rate, over N, which is 4, raised to the 4 times 3 because there was 3 years. Good so far? Agree? Everyone follow where my math went? Okay. I'm going to take the 2664.49. I'm going to divide that by 2,400. So if I divide this on both sides, because I'm just trying to get my variable by itself, that's going to give me 1.110 equals 1 plus R raised to the 4th raised to the 12th. Okay. Thoughts? What should we do? I have an unknown variable. I have the unknown variable r in there. Agreed? It's in a strange location. Agreed? I have a quantity raised to the 12th power. Any idea how to solve it? How should I undo this? Do what? Oh, yeah, 12th root. I want to take the 12th root of both sides. Now, I know that you don't know necessarily how to find the 12th root, but this would be the same thing as the 1.110 raised to the 1/12th power. That's how you find the 12th root. Okay? So I'm going to go 1.110 raised to the, in parentheses, 1 divided by 12, the 1/12th power. So this is going to give me 1.0087. So that means that if I extend the page, I'm going to get 1.0087 equals 1 plus r over 4. Subtract 1. Algebra 1 says I'm going to take the 0.0087 and multiply it times 4. So my rate is 0.0348. This as a percent will be 3.48%. If you gave this number without a percent, you're fine. If you gave it with a percent, it has to be that one. So a little logical thinking. I don't think it's impossible to do, but it's just a little bit of logical thinking on it. All right. Deep breath. Again, if you get hung up on something, ask me. Okay? If you can't remember how to take the 12th root of something, if we gave you something like that, I will remind you, it's the 1/12th power. Okay? Deal? But if you don't ask me, I don't know if you're missing it. So just ask me. And I know I'm kind of opening Pandora's box. You know what Pandora's box is during a test? The first student who asks a question, all of a sudden 16 people have the question. It's like, uh-oh. So let's move on. Graph this function. Okay? Now, I'm going to allow you to use a graphing calculator on this test. But I'm expecting some true values. Okay? Things that I want to know here is if I graph this, I know I have a y-intercept or an asymptote like right here. If I plugged in some values, if I plug 0 in, 2 to the 0 power is 1, so I get here. Maybe if I plug 1 in, 2 to the first is 2. Maybe even if I plug 2 in, 2 squared is 4. So I definitely can see my points done. That's our parent function of an exponential function. So now, with this known, I want to graph this. Tell me something you know about this equation. Yeah. Good. The horizontal asymptote is -3. Okay? So this is going to go right 2 down 3. And if you know the shifting that's going to take place, you know all the shifting that's going to take place, you can do this entire problem. I don't think this was a difficult thing to graph. So I'm going to go right 2 down 3. Wait, 1, 2, 3. I'm going to go right 2 down 3. I'm going to go right 2 down 3. 2, 3. That's what the graph looks like. Okay, if you establish the points, the shifting becomes real easy. If you don't have any points established and you just try and draw, you mimic what was on your XY axis on a graphing calculator, I'm going to take some points off. I've got to see those points. Those points are going to tell me that you understand the shifts that are taking place, not that you just knew how to plug it into a calculator. Make sense? Does everyone feel comfortable how I got these points? Anyone like, plugging a number in and getting a value out, input, output? I hope you're okay. Can I move on? All right. So same exact idea. 3 to the x. Things I know, I have a y or an asymptote here. Let's plug values in. 3 to the first, 1. 3 to the first, 3. 3 to the second, 9. Again, I can see my points. Okay? Asymptote's what? 2. What does the negative out in front do? If I didn't have this negative here, if this negative wasn't here, all my values would just have moved up 2. Agreed? What does the negative out front do? What does this do? What do you want to think it does? It's going to make it go from this graph to this graph. This graph to this graph. It's flipping it over the asymptote. But what did our asymptote change to? 2. Okay, watch. Ready? I'm going to go up 2. How far above the asymptote am I at right there? 1. It's going to flip over the asymptote. Go to here. I'm going to go up 2. How far is this from the asymptote? 1, 2, 3. So it's going to flip over. 1, 2, 3. This one went up 2. Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. So now it's going to be here. 1, 2, 3, 4, 5, 7, 8, 9. So I realized I counted up each point and then I flipped it over the asymptote. It was that far above or below the new asymptote once I shifted it. Huh. I think I'm okay, but I hope you are too. Questions about that? Can I move to the next graph? Okay, we're going to graph this. Asymptotes here. Plug 0 and 3 to the 0 is 1. 3 to the first is, 3 to the first is 3. 3 to the second is 9. Parent function's that. Ooh, baby. Original graph is growth because as I go to the right, it increases. The reason it's growth is because my base of my exponent is a value bigger than 1. Now it's going to become decay. Now it's going to become decay. Went from growth to decay. do you think? So let's say we're stuck at this point. Do we agree? Do we agree the asymptote's the same? Okay, we're good, right? So let's say you're like, I can't fathom this in my head. What's going on? Well, let's plug 0 in. 1/3 raised to the 0 power is 1. Okay, so this point agrees. Okay, I'm okay. I got 1 point. 2 more to go. How in the world are we going to figure that out? Well, plug 1 in. 1/3 to the first is 1/3. So 1 comma 1/3 is like here. Agree? Maybe plug 2 in. 1/3 times 1/3 is 1/9. Is that right? Notice how that's getting smaller and smaller. Oh, that's what this one's doing. So if we get stuck on it, we already know how to plug 0, 1, and 2 in. Go for that. Yeah. Oh, hey. You're making it work? Cool. So if we have these values, which these are the same as these, I think we could do it. Now, do you think I'm that worried that you know exactly where 1/3 is or where 1/9 is? Not really. But if you get hung up on that kind of problem, go back to your go-to. Go back to your, I can plug in some values and make it work. Don't plug in real silly values. Don't be like, oh, let's plug in 16 for x. 1/3 to the 16th power. It's 1/246,318. I'm just lying. I can't make that up that quick in my head. But go to your go-tos. Okay, the plug-in. Does that make sense? It should be decay. I told you it was decay. Does that make sense? It's decay when it's graphed. All I did is I plugged in the numbers I knew. I knew 0, 1, and 2. Okay, I'm not quite sure what the graph's going to look like, but I know I can plug 0, 1, and 2 in. And I don't know if I get decimals. I know that a decimal is between 2 values. Are we okay? Can I move on? Okay. Asymptote, 0. Right? Because it's not added or subtracted anything. Graph the function, highlight the asymptote. We have the asymptote. State both the domain and range. Oh, are you kidding me? Well, the domain of these will be negative to positive infinity. I'm fine with that. Okay. Do we think it's growth or decay, and why? What is my base? 1/5. Is 1/5 between 0 and 1? It is, so it's got to be decay. All right, again, let's say we're getting hung up on the problem going, okay, well, don't panic. Plug 0 in. 1/5 to the 0 is 1. 1 times 4 is, oh, I feel a little bit better. I got at least 1 point. So is it doing this or is it doing this? Well, it's decay because the 1/5 is smaller. All right, plug 1 in. 1/5 to the first, 1/5. 1/5 times 4, 4/5. 4/5 is 0.8. So I got 1 comma here. Oh, I know what this is going to look like. It's going to look like this. All right, so now we have to answer the range. The range is like the elevator going up and down. It's the y values. It's going to be a round bracket at 0 because 0 is an asymptote. Asymptote we can't cross. We're going to get really close to it, but we're never going to cross it or touch it. And it's going to keep going upward forever, so it's going to go to infinity. There's our domain and range. Yeah. The range? Yeah. Okay, so my asymptote is the x-axis, which is 0. Y equals 0, right? So being that this value, this part of the graph is getting really, really, really close to it. In really bad calculus classes, they call it the squeeze theorem or the fly swatter theorem. which means we're getting really close to something, but we're never going to cross it. Okay? That's how I know it's 0. But it's a rounded bracket at 0 because I'm approaching it. I'm not going to get it. If it was a square bracket, it means I would touch it. Is that okay? Okay. So basically, the range is the asymptote, rounded bracket, asymptote, to infinity. If it opened downward, it would go negative infinity up to asymptote. Does that make sense? Cool. Hardest part of this test, but guess what? You got to use a calculator on it. You're like, oh, E. What's my asymptote? Still here? Okay. My go-tos. If I plug 0 in, E to the 0, it's got to be 1. Okay. Now, if you weren't allowed to use a calculator, I would say you have to know this. E to the first power is about 2.7. Okay? Being you have a calculator, go E to the first, and it's going to give you 2.7 with a big old long irrational decimal. So 1 comma 2.7, so it's like right here. Okay? We feel good about that? Now, graph this. What's my asymptote? 3. So moved up 3. And I have the negative out in front. Oh, jeez. Come on, stirrup. I don't remember this stuff. Okay. Well, let's use our go-to. If I plug 0 in, 0 plus 1 is 1. E to the first is 2.7, negative. So you negative 2.7 plus 3, which is, careful, 0.3. So 0 comma 0.3. 0 comma 0.3, right here. Uh-oh. Okay, hang on. If I plug 1 in, oh, I don't know what e to the second is. I can't do e to the second. What do I have to plug in here to make that 0? Negative 1. So then I get e to the 0, which is 1. That becomes negative 1 because it's negative out front, plus 3 is 2. So negative 1, 2. Oh, that's what it is. Okay, I did the go-tos. Okay, try not to overthink it. When you start plugging large values in, you're like, okay, let's plug in like e to the 6th. That's like hundreds of thousands. So try and keep it simple. Try and keep the 1s, negative 1s, maybe 2 at the max. Hey, for the blue, the domain is negative to positive infinity. The range is negative infinity to 3. Rounded bracket. I'm just looking at the blue. I know it didn't ask for it, but I wanted to show you a negative one coming from negative infinity. It's coming from the bottom up to the asymptote. It approaches the asymptote, which is 3. It does not cross it. That's the way it's not a square bracket or a hard bracket. Yeah. On these type of things with asymptotes, you will not come across a square bracket. Yeah. So we eliminate the square bracket from your thought process for this quiz. Okay. Oh, thank goodness. It started getting a little easier. Definition of E. Definition of E. Well, I'm not real sure, but I'm pretty sure I have no idea what the hell that means down there, so it's got to be the definition of E. 1 plus 1 over n raised to the n. Yeah, I think we remember talking about that. All right. Continuously compounded is the PERT. Depreciation means it loses value. That means we have to have subtracted my rate. Compounded interest, compounded interest. Okay? The quiz will be very similar to the review worksheet. You will need to be able to identify the formulas, etc. Was there any more to this? Oh, 9F we're actually doing on Monday when we have everybody here. And you all know Monday's like a totally weird schedule, right? Okay, so my friends, let me just take a look. I want to make this work for you because I know that we had spring break, we had everything else. So my friends, what I'm going to do is, why don't I do this for you? I will worksheet 9E. I'm not going to collect. But what I will do is, if you want to take a look at it before next time, I will also have a video of 9E all worked out. And that'll be a good review for you on the quiz. So between today and next time we have class, I would say it'd probably be a really good idea if you took a look at that video while taking a look at the worksheet. Maybe try the worksheet and then watch the video. If you're running out of time, maybe watch the video with the worksheet in hand. Make sense? That cool? Everybody happy? Can I stop recording? He was recording? Yeah, sorry. Say